we are Censible Solutions, and we are presenting the Geographics, Location, and Demographics Organizational Software, also known as GLaDOS. I'm Alexander Belfilio, team lead.
I'm Blake Jadeo, I'm the lead designer.
I'm Joel Erickson, I'm the QA lead.
And I'm Alexander Harris, and I'm the documentation lead.
And our client is Jennifer Hackett of Monastash Mapping, and our advisor is Dr. Anvik. We will quickly explain to you what exactly we mean by graphical locations and demographics with GIS, the problem we face, our program solution, and as well as a demonstration of our use cases and our current level of implementation, along with risk assessments and future plans. So what is GIS? GIS is turning raw data that is brought in from census, from either the government every 10 years or other societies such as ACS every year. This includes demographic information like race, gender, as well as population in areas and income. This is very useful for companies who want to have a quick view of seeing where income levels are for where they should position their products or stores next. And that is what our client, Jennifer Hackett, does. She is in charge of Monastash Mapping, which is a GIS consulting firm. Her current problem is she gets this data in, but the most commonly used software, ArcGIS, which is a mapping software that produced that lovely image before, is not compatible with the information that she gets in. So she needs to find a way, an automated solution to fix this conversion problem, because currently it's a long, tedious process that takes several hours of her time to do. So the problem, the census data is hundreds and hundreds of tables and hundreds more categories, and it's all not very well organized or clearly labeled. The other problem she has is that a lot of it is broken up, and she needs to have big sums and be able to combine stuff together and have simple naming mechanics in order to get her point across to her clients when presenting her consulting. So our solution is, first and foremost, fix this conversion problem. Get her data working with ArcGIS so she can start working on what she needs to do now. Right now, we have a high-level overview of a CSV table, which is what the original census data is, but it's not compatible because of a small error. So what we propose is having an import function going to a database or some other method of storage, and then using either query or parsing to go into a filtering process. This will let her pick and choose the data that she needs, as well as simplify it. And then it'll output a form that will be compatible with her software. So currently, we are using Eclipse IDE. We're using Trello for organizational purposes and bug tracking. And then we're using Mercurial along with Bitbucket as our repository in order to keep track of version tracking. We have an open team structure, so we all have our roles, but we interchange a lot in case someone gets hung up on a particular problem. We're also using an iterative process. This is because when our client came to us, she wanted the software first and foremost to do one simple thing, fix this conversion. But she wanted to be able to keep adding on recommendations. So an iterative process gives us the ability to get the product that she needs out right away, and it allows more adding on to it.
Alright, so some of the requirements, typically the most important ones, are like to convert the original files into the file that is compatible with ArcGIS. You know, obviously that's what she needs. We also need to be able to export into population percentages based off the total population in a given area as well, because for her, raw data is almost useless. Percentages are much more informative, because you can have blocks of land that only have like 5 people on it. And so if it says that there are like four people here who earn this much versus another place that has, say, like 100 people and the exact same amount of people are in that same income block, you'd have the same amount of, looking at just raw numbers, you wouldn't get as much information. You also need to be able to combine table columns because, again, with like the example with the income is that the income on the census data isn't necessarily that informative. There are the blocks of which the income is spaced out isn't necessarily what the client wants, so she needs to be able to put columns together to make her own blocks of or different levels of income. You also need to filter out the unwanted columns. So if she's working with income, she doesn't really care about the ethnic data. So like how many African Americans live here, how many Native Americans live here. She doesn't care about that, but that's still included in the original file. So we need to be able to take that out. And then we need to have accuracy down to what's called the block level. There are about 5 levels of this GIS data, starting with state, county, tract, and block. There's 4, excuse me. Then there's some desired functional requirements, something that she wants, she would like, but the other obviously are more important. That is to rename tables. Actually not tables, but columns. Some columns have really odd names. Like we were shown we have a set of data where all the names are in a code. Like it was like 3A05.2.1. That means nothing, but it just looking at it, but it obviously has a coded meaning. But that doesn't tell her client anything. So she wants to be able to change that using our solution. Also, in kind of like a file that the file she wants to be able to keep obviously different versions of the file as she works on it, so that way she can go back and fix any mistakes or add anything to it. It also it's going to be a web-based application so that she can put it on her website that she has. Also, we need to store, actually that's, anyway, a guide, and then we also have a guide for the ACS, where to find the actual raw data. I mean, she knows, but not necessarily someone else who might be using this may not know what table they're looking for or where to go, so that's for that. And then for non-functional requirements, we have, we obviously need the server space to hold data and more years of census data. Enough bandwidth to handle the multiple users uploading and downloading their files, and as well as it needs to be reasonably paced. It can't be a slow upload, download, or our processes can't take too much time. And here's the basic web map of our website. We have our homepage on the left, and it goes into an import page where they import one of 2 types of files. And then we go to where they actually filter whatever file they're currently working on, and they go to a page that shows them a small preview of the table that they have created or filtered out, and then they can download the file that they have filtered.
And I'm going to talk about a rough prototype that we presented to our client. First, you import a file and select the file. Then, obviously, your file appears and you move on to the next step. You can you can filter out the data that you want, so you can get more accuracy. And select columns to rename and combine. You can also check if you want actually raw numbers or if you want percentages, and then your new column appears and is ready to be exported. And then you export the file and save them to the server, and then download them to your desktop. And I'm going to present the demonstration we have for you as well. This is the homepage for our web application. Here on the homepage, there's a project overview. It tells you a little bit about our project. The documentation page currently has our iteration reports, but eventually we'll have a user manual. Currently, we can upload files. And we can upload multiple files, actually. And then from here, this is mostly just a horizontal prototype. We can choose whether you want ACS or census data, or you're using ACS or census data. You can choose the demographic you're trying to get information about, age or race. There's also the summary level, which you can choose between state, county, tract, or block, depending on what you're using. And you can choose different categories, and it will give you the relevant information for those categories. So let's choose those. And then this will give you the appropriate column headings from the data you filtered, and you can add multiple column headings over to be exported. Currently, the modify button doesn't work, but it would allow you to use raw numbers or percentages. You can rename the column names and combine different columns. From here, we move here and where you can download the files. By clicking on them, it opens up the file in Excel, so you can get a preview before you save it locally. That is our prototype for now.
Okay, so I'm going to talk a little bit about just our experience that we've had working with our clients, and also a little bit about acceptance testing that we did, showing her our paper prototype, and also a little bit about our risk mitigation strategy. Because our client is local, we've been able to meet with her about every week or two, and we also are in contact with her through email on a pretty consistent basis. When we did show her the paper prototype, she had pretty good positive reaction to that. She gave us some suggestions, though. We're going to talk a little bit about some of the feedback that we got from that. When we showed her the paper prototype, she was kind of concerned about the intuitiveness of actually the process that the user is going to go through uploading the file, and then it was more focused on actually the data manipulation. She thought that the steps that you go through weren't kind of illustrated well. And so what we kind of have done a little bit, actually, Alex showed you on our actual prototype there, was we're going to include some more icons, things like arrows and some explanations, things like that, and maybe kind of rearrange the interface a little bit to make it more obvious what is actually happening to the data as you're importing it and manipulating it. Another suggestion, or something that came up during the reaction to the prototype, was maybe giving some kind of tutorial information, kind of a step-by-step page linked to from our web application that would kind of take the user through actually going and downloading the information. And as we were talking about that actually led to some added functionality that I'll talk about here in a second, which is going to be something that will let the user kind of do a search by the type of information, the kind of data that they're looking for, and then it will then tell them which data source has that information, if any, and then give them a link where they can actually just click on it and go directly to that data. So for our risk mitigation, one of the top ones is there's really not any consistent format that we can count on for like future census data. Between 2000 and 2010, they changed their data format quite a bit, the way it's organized. And so we need to have our data structure be flexible enough to be easily modified that when the 2020 census rolls around, that we'll still be able to use this that she'll still be able to use this and that it'll handle those changes, whatever they'll be. And then as far as the additional functionality that we talked about with the guide for data sources, what we decided to do with that is kind of divide our project into a couple of different phases where the core functionality is going to be prioritized, and the additional guide that we discussed is actually going to be kind of a phase 2. We may even kind of reallocate our development where maybe half the team works on phase 1 and half the team works on phase 2, so we can kind of do concurrent development on those. With the availability of server storage space, that's really something that at this point in our development, we're just designing this for one user. She has plans or ideas about this becoming widespread as a web application, and so at some point we're probably going to exceed the space that we have available to us as a student project, but for right now that's not really something we're going to address. We'll deal with that as it happens. And then the last risk there really has to do with future versions of GIS software. Whether or not our output is going to work with those, that's something that's kind of beyond our control at this point. So it kind of has a marginal impact, and depending on what those other programs may be and what their data formats, we might, if we have time, choose to implement some of those. So I'm going to pass it back to Alex for the...
So, summing up, we hope to have this as a web-based open product for anyone who wants to get involved in using ArcGIS and make it easier for their lives, especially for people like Jennifer Hackett, whose livability and company rely on it. Do we have any questions? Yes?
How long did it take you guys to name your product GLaDOS?
It actually was originally GLAD, so we got the catchphrase, don't get mad, get glad, because of how frustrating it is to rearrange this data, but GLaDOS was too good to pass up.
And follow-up, are you guys concerned of legal issues with how?
No, because they have a lowercase a and ours is uppercase, clearly. Okay. Any more questions?